All right, PreCalc. I don't know if I want to tell you that this is going to be more fun or more frustrating. I'm not sure, but we're going to take our sine and cosine off of our unit circle and we're going to graph them. Okay, we're going to go into a coordinate plane. We're going to take values from our unit circle and we're going to graph them. So we're going to start here with the graph of the sine function. And sometimes it's handy just at least to get the first visual is to think of some values from your unit circle. So if you think of your unit circle, okay, here it is, and we start at when we take, let's say, the angle 0, okay, whether that's in radians or degree, it doesn't matter, and we're at this ordered pair 1, 0, okay? So that's where we would start at. Now, if we're doing the sine, which we're doing here first, we would use all of our y values as we go around. Okay, so I start at, when x is 0, my sine of x is going to be 0. So I start at 0. So one key thing to always remember about a sine function is we start at 0. Okay, then you'll notice the values across my x-axis here. I'm not using like 1, 2, 3, 4, 5, 6, 7, okay? And you don't have to. You just have to choose what your scale is, and you need to stick with that scale. You'll notice that the points that I'm using on this scale are by pi over 6. So pi over 6, pi over 3, pi over 2, then I would go to, let's see, that's 3 pi over 6, 4 pi over 6, which is 2 pi over 3, and then 5 pi over 6, and then pi, and we're going by increments of pi over 6 this time. What you see right now is what we call a period of my graph. And if you think about it, I started at 0 and I ended this graph right here at 2 pi. Well, that's one time around the unit circle, okay? So you'll notice that the highest point I get to is at pi over 2, and that's at 1. The lowest point I get to is 3 pi over 2, which is negative 1. And then I have all these points in between. Pi over 6 would be at 1/2. Pi over 3 is at radical 3 over 2. Those are values we get off of our unit circle. You'll see them in my table down here as well. We go from there. Now, some things to talk about when we graph the sine function. The domain is definitely anything we want to plug in, negative infinity to infinity. Obviously, we plugged in points that come from our unit circle because we know the values that go with them. Okay, but this graph actually can continue going and it'll continue to cycle from either direction, right? And it can keep going. It goes from left to right infinitely, okay? What we will often do in PreCalc is set a limit and say just graph between these points, okay? Or graph one period. But just remember that there technically are arrows here and these can go on and on forever. Okay, the range of this parent function, and I am stressing that we're on the parent function right now, is from -1 to 1 inclusively. That's where the brackets come in, okay? Because the highest point is 1 and the lowest point is -1, and we have all these points in between. The graph never rises above 1 or falls below -1 of the parent function. As we do transformations to it through these notes, you will see that that changes, but the parent function's range is from -1 to 1. The period is 2 pi. Now, a period, that's something new for us probably, as far as in math to use the word period, and I don't know if you've done anything in physics yet that you've used that word period, but what we're talking about is we can see that this is going to repeat itself over and over and over. We've talked about that with the unit circle, that we can go from 0 to 2 pi, and then our values keep repeating, so we could say 4 pi or 6 pi or 8 pi and keep going, but we're going to see the repeat of the values through there. So one full period is 2 pi, and then the graph's pattern keeps repeating itself over that length of 2 pi. And by the way, this is of the parent function because our period could change depending on the transformations of our graph. The sine function is an odd function because if I plugged in -x, I would get the negative, and let's just tie it back. We already know sine is odd, okay, so we know that's going to happen. But if you go back to the rules of an odd function's graph, it should be symmetrical around the origin. So if you think about this origin right here, if I decided to spin this 180 degrees, my graph would be the same image as I see now. So I do have symmetry with respect to the origin with the parent function, okay? So this is our parent function. I want to stress that we start at 0, 0. We go up first, then we come back down, and we hit pi 0. and then we go down beneath that to -1, and then back up to 2 pi is at 0. Okay, so that's my parent function. That's when nothing else has happened to it. That's where my graph goes. I want to stress to you that I am looking for, anytime we do one period of a graph, I'm looking for, I want to say 4 points, okay? From your starting point, I want you to graph 4 distinct points, okay? And I've got a lot of colors going on here already. So if you think about it, here's my starting point. My 4 points, to be honest, we always graph the end point first because it's where I start and where I end, okay? And then I want a halfway point, and I want a halfway between that and a halfway between that, okay? So you're going to see these, I'm going to kind of graph these 5 points, but really when we start figuring it out, we try to start at our starting point and then we get 4 points past that, okay? And then that gives us 1 full period. So kind of keep in mind that I'm looking for 4 points past the starting point, okay? So that's my sine curve. Let's go ahead and start doing some variations on this sine curve. And every time we do it, it's going to help maybe hopefully solidify what the actual parent function is as well, so it gets easier to graph. Okay, so you'll notice that to my parent function this time, I've added one little thing, and it's our a. It's in front of the sine x, and this a is the amplitude. Okay, one thing I want to stress is the absolute value of a is the amplitude. I will sometimes call this, or it kind of goes back and we feel like it's the slope, okay? Obviously this is not linear, so you can't have a slope, but you're going to feel like it does the same job as what a slope does on a linear equation, okay? The reason we say the absolute value, because if there is a negative on it, that will end up with a reflection, a vertical reflection, just like we've had on every other transformation. So we really only care about the actual value of this number. And once again, you're going to kind of see the same thing we're used to. If it's bigger than 1, I'm going to stretch my curve out vertically. And if it's less than 1, I'm going to shrink my curve vertically, okay? So keep that in mind. That's what we're doing. And just a quick visual, if you have your normal curve that looks like, and let me start where my normal curve would start. My normal curve looks like this, right? A stretch or shrink might do this, okay? It might just stretch it like that. That's what this amplitude is going to do. So one thing that you'll notice when I put this on a quiz or a test is I'm going to ask you often, what's the amplitude? And when I talk about the amplitude, you just need to tell me the number, okay? So the amplitude on this particular equation, okay, this is what we're looking at right here, is my a right here. My amplitude is 4. Even if that said -4, you would simply say the amplitude is 4. We will always give a positive value for the amplitude. Okay, so that we can see this well, it says graph y equals sine x and y equals 4 sine x for when x is between 0 and 2 pi. Okay, I stressed to you earlier, and I'm going to stress it again. Always know your starting point. And 4 spots out, I want you to put your period, okay, which is 2 pi. So 1, 2, 3, 4. On this one right here, I'm going to put 2 pi. Okay, so from your starting point, 4 points out is 2 pi. Halfway between that, it would be pi. And if I want to go halfway between those, I get a pi over 2 and a 3 pi over 2. Okay, those values should seem familiar to us because of the unit circle. I'm going to be honest, I often don't write these in between ones because it gets confusing to me. Okay, or it just gets cluttered in there, so sometimes I leave those out, but know what they are. Okay, so this time I have an amplitude of 4, but I'm also going to graph my normal, which is y equals sine x. Okay, by the way, the period, we already talked about this, right, because we haven't done anything else, is 2 pi, and that's always the 4th mark out. And I can't stress that enough. If you make the 4th mark out, your period, things are going to go smoothly here. So on my normal sine curve, okay, oh, I need to be careful because I'm never going to fit everything in here. I have an amplitude of 1 and -1, right? My amplitude is 1, which means I go as high as 1, come back in the middle, go as low as 1, and I'm back here. So that is my normal y equals sine x. Okay. I'm going to switch colors here so you can see this. Now I'm going to do an amplitude of 4, which means that my slope, or how steep I get, or how much I stretch, is going to be 4. So instead of going to 1, I'm going to go 2, 3, 4. And my lowest point, instead of going to -1, is going to be 1, 2, 3, 4, negative 4. So I still start at the same point, but I go as high as 4, back to that middle point, as low as negative 4, and back up. And I'm not super accurate there, but that's where I'm going there. So that's my y equals 4 sine x. It has an amplitude of 4, which means I stretched it. My period stays the same at 2 pi. Okay? It's continuous, okay? If you think about it, yes, our unit circle, we only list values at pi over 6, pi over 4, pi over 2, and pi over 3 and pi over 2 in that first quadrant. But to be honest, we know there's many more values in between, so we have this continuous curve that catches all the values in between as well. Okay, we definitely want to hit this high point of 4, this low point of negative 4. We need our zeros where they belong in between as well. Okay, let's move on and do another one. The more we do, the easier these get. All right, I'm trying to add one little piece at a time so that we can continue to feel like what we know what's going on. So you'll notice this time I still have my amplitude, okay? And this time though, I'm adding a b value that's in with the x, okay? Again, this we should be thinking it's going to do something horizontally, because anything tightly connected to the x does something horizontally, usually does the opposite of what we think, okay? That holds true for all functions. And yes, this sine curve is a function. If you think about doing a vertical line test, it's going to pass it. It's fine, okay? So it says the amplitude is still the absolute value of a. That doesn't change. But this time the period, now what we do is we're going to take our normal, which is 2 pi, and we're going to divide by the b value, whatever that b value is. And that's going to give us our new period, okay? Because 2 pi is the standard on the parent function, but it can change if there's transformations done to the graph. So now our cycle is going to go from 0 to 2 pi over b, okay? Whatever our b value is. Okay, so let's get some things straight and organized on this one. Okay, so let's start with our amplitude. And then we're going to go to our period after that. Okay, so amplitude is always this value in front, right? So that's going to stay 1/2. And sometimes I look at this and I'm like, why did I use 1/2 twice? I don't know. Okay, so that's my A right there. My B is what's tightly connected to the X. So to find my period, the normal is 2 pi, and I divide by the B value to find my new one. So I get 2 pi divided by my B value, which is 1/2. Now remember, that is keep, change, flip. So that gives me 4 pi, okay? Now we stated this on the first page. What that means is 4 lines out, I want to see 4 pi. I start at 0, 1, 2, 3, 4 lines out is 4 pi, okay? I do want to stress here, and I probably should go back to that last one, that they tell me I'm going from 0 to 8 pi. So if 4 pi is one period, if I go, and that was 4 lines out, halfway between that is 2 pi. So the next 2 lines would make it 6 pi. 2 more lines would make it 8 pi. Okay, so I'm going to go to 8 pi just because they tell me that, okay? One thing, go back one page because I do want to stress this, okay? Quick note on this one, the domain here. Because they gave me this, it sets my domain. Okay, usually it'd be negative infinity to infinity, but because they give that to me, I'm going to include from 0 to 2 pi because they told me to limit it there. Okay, you wouldn't have to, but that's where they told me to limit it, so that's all I graph. My range on this one, remember the normal range on the parent function is from -1 to 1. But because my amplitude is 4, my range is going to be from -4 to 4. For both my domain and my range, they're included because the points actually hit those, touch them, and everything's included on those, okay? All right, back up to this problem. So sorry, I forgot to do that, and I wanted to go back and do this. So if we were listing domain right now, I'm going from 0 to 8 pi. But be careful, it's only to 4 pi that is the period, okay? So by the way, that means if I start at 0, I'm going to end at 0 at 4 pi. Okay, my amplitude is 1/2. Okay, so my normal up here is 1 and -1, right? So 1/2, if you think about it, what I have is a shrink. Okay, vertically anyways. So I need to make sure I end up at 4 pi. Halfway between here is at 2 pi, so my highest point is going to be at 1/2. I go down to 2 pi, I go down to my lowest at -1/2 and back up. So my curve is going to go like this. That is one period, okay? I need to hit all those points in one period. If I want to continue the graph to 8 pi, because it did tell me to do that, once again, 8 pi is going to finish one full period, halfway between a 6 pi, so I need to go up again as high as I go, between 4 and 6 pi, and as low as I go between 6 and 8 pi, and I continue this curve, okay? My domain is 0 to 8 pi. What's my range this time? Well, my lowest point was -1/2. My highest point is 1/2. Everything is included on that one. Okay, so if you think about it, my normal, I'm just going to graph it so you can see it, okay? My normal would have gone up as far as 1, back down, okay? That would have been my norm. That's y equals sine x. Why does that say yes? Okay. Y equals sine x, okay? And then the green one was actually 2 periods, right, is what I ended up graphing because of the given domain. But one period only goes to 4 pi. Okay, here's what's nice, okay, and we could do this differently. I could ask you on every graph to always 4 lines out, make it 2 pi, okay? What you would notice here is on the 2 pi, you know what, I need to completely redo this, okay? I'm going to mess you up here. Okay, I need to redo at least this much of it. And I apologize. 1, 2, 3, 4. This is what happens when I haven't graphed these in a while either. Okay, so we went up, down, down here. Okay, so this was my graph, and that was my y equals 1/2 sine 1/2 x. Okay, let me fix that parent function because I did not have it correct. Okay, the normal parent function goes between 0 and 2 pi. Okay, so my one period would have gone up. Here's one period of y equals sine x, okay? Sorry, if you think about it, because this one stretches, this is one full period right there. It's it goes opposite what we think it is because it's 1/2. It's actually stretching horizontally, okay? And that's what that b did to it, was stretch it horizontally. So my black would be my parent function, but that first cycle or the first period of the green is my actual y equals 1/2 sine 1/2 x, okay? So it's stretched out horizontally because of that 1/2. All right, moving on, we're going to add another change or transformation onto our graph, okay? I have my amplitude staying the same, okay? My b is still going to determine my period, but this time I have a -c inside the parenthesis with it. So we remember that anything tightly connected to the x is going to affect it horizontally, okay? Now, one thing I really want to stress to you, okay, this is super important to notice, is c, phase shift is going to be c over b, okay? But when we get our c, it's going to be opposite the sign going to be opposite the sign of what you see. Okay, I can't stress that enough. We've seen that before with vertex, with different things, that when we pull it out of the parentheses, it's opposite the sign. So when we figure out our phase shift, it is going to be opposite the sign. Okay, and if you think about usually in any other functions, if you have a plus or minus a value inside with your x, it moves it left or right, opposite what we think it will be. That's what a phase shift is. It's moving it left and right. It's taking our phase that usually goes from like 0 to 2 pi in the parent function, and it's going to shift it so the starting point is at a different starting point. That's what a phase shift is going to do. Okay, so just so we know, well, I'll come back to this in a minute. Okay, here's our function. Lots of stuff going on here. Y equals -3 sine of 2x plus pi over 2. Okay, amplitude. The amplitude never changes. It's whatever number's there. The negative doesn't matter. My amplitude's always a positive value. I get an amplitude of 3. So we know that we're going to go as high as 3 and as low as -3. You'll notice my graphs that I give you are very vague. I give you something to start with, but I don't label points because you're going to make your labels off of your information there. So my amplitude is 3. I'm going to go for the period next because that's how I'm going to label my horizontal axis. Okay, remember that's 2 pi over b. My b right now is 2. So I'm going to do 2 pi divided by 2, which is going to be pi. Okay, so 4 lines out, 1, 2, 3, 4 is pi. It does not matter if you have a phase shift or anything. We always do the period first, and 4 lines out is pi. That means 2 lines in is pi over 2. 1 line in, every 1 line would be pi over 4, right? Okay, so phase shift, this is telling me how far I'm going to go left or right. This is always c over b. Okay, my c is opposite what I think it is. So it's opposite this sign, so it's going to be negative pi over 2 over my b, which I already decided was 2. So my c is always opposite the sign you see. Okay, you got to keep that in mind. C is opposite that. All right, so I have negative pi over 2 divided by 2, which is the same thing as keep, change, flip. So what I get there is negative pi over 4. Okay, that is my phase shift. That means I'm moving left. The negative tells me that pi over 4. Well, remember, if my second line is pi over 2, half of that's pi over 4. So I'm actually going to start over here at negative pi over 4. One little line is a pi over 4 each time. So I've shifted my starting point over to negative pi over 4. That means instead of ending at pi, I'm going to end 1 to the left because everything moves 1 to the left. Halfway between is going to hit a 0. Okay? Now, quick note, because this is the first time we've seen it, I also notice I have a negative here. Okay, so if you think about it, my normal graph starts at 0, it goes up, it comes back down, and it ends back at 0. Typical like that, okay? As soon as we have the negative in there, that is a vertical reflection, so instead of going to go up and down, we're going to start and we're going to go down and then back up to do a cycle. Okay, so this is the negative out front is going to do that here. Okay, so I'm going to start at my starting point, which was shifted negative pi over 4. Instead of going to my highest point first, I'm going to go to my lowest point first at negative 3, back to 0, then up to my highest point and back to 0. So here is my 1 period of the function. And you'll notice I said 1 period of the function. So I didn't give away my domain with that phase shift. I just said 1 period. So if this is what I do, I would say my domain started at negative pi over 4. And it went to what's halfway between pi over 2 and pi? 3 pi over 2. Oh, I'm sorry, over 4. And if you'll notice how much distance or space is between negative pi over 4 and 3 pi over 4? Pi, which should match up with my period. Okay, what's the range on this curve right now? It would be from negative 3 to 3 because of that amplitude. Okay, so the phase shift is going to change our starting point. Okay, that negative out front started us down instead of starting up. Okay, so quick note, let's see, 4 spots out before I get to 2 pi. Okay, my normal graph, let's see if I can actually manage to do this without messing it up. My normal would have gone like this. Okay. That would have been my y equals sine x, right, with nothing else changing it. Why does that look different than before? Because each time I'm allowing the period to set my scale so that it's just easier for you to follow the same pattern. But if I would have graphed these on the exact same graph as earlier, you would see that vertical stretch with the 3, up 3, down 3. You would see that reflection point. There's a lot going on there. 1, 2, 3, 4 different things going on there. Okay, the period, because of that 2 inside, this 2 right here, normally anything that happens horizontally, remember, does opposite what we think. So instead of stretching it, it shrunk it. It went closer together, right? And then we had that shift over as well. All right, let's try another page. All right, you'll notice we're changing from sine to cosine. Okay, an initial glance at this picture Does it look like our graph changes very much? It definitely changes a little bit, but you still see kind of that same up and down hills that you saw from the sine function. Okay, some quick reminders. Remember our unit circle? 0 starts at 1, 0, right? But remember, this time we're looking at the x values, not the y values. Because of that, our first point is at 0, 1. Notice we start up. We don't start at 0, 0 anymore. That went with the sine. We start at 0, 1 for cosine. Okay? Here is one full period. Okay, so you'll notice if we do one full period, it'll look like you start at the top of the hill, you go down to the valley, and you come back up to the top of a second hill. And that's one full period from 0 to 2 pi. It follows those values from our cosine, which are our x values around our unit circle. Okay, so once again, you'll notice halfway through, pi is at -1. That's our lowest point. Then we get back to 2 pi, which goes back to our starting point. We have all those values in between that come from our unit circle, although we know there's an infinite number of values in between those as well to get us this continuous curve. Okay, my domain is still -infinity to infinity, just like it was with the sine. We can keep going, right? And you'll see this has those arrows there and it keeps going. This is one period, but we know it can keep going multiple times and repeat those values over and over. My range on my parent function is -1 to 1, so it keeps all those values between there, which makes sense because the highest and lowest we ever get for a y value is -1 or 1 on our unit circle. The period is 2 pi, just like on the sine curve, and everything repeats everything in 2 pi. Remember, again, parent function, because once we do transformations to it, it will switch. The function is an even function, okay? We know this from earlier. We've talked about cosine being the even function. But the graph helps you notice that because it means that if I folded it on this y line, it looks the same on the left as it does on the right, okay? So it has an even function because it is symmetrical across the y-axis. Okay. This next line, I just slide it in here, but I want to make sure you notice it. The graph of a sine and cosine functions are called sinusoidal graphs. Okay, great big word for you there, sinusoidal. What is a sinusoidal graph? What it means is when you look at the cosine curve, it really is just the sine curve with a shift of -pi/2, a phase shift. So if you think about it, if I shifted -pi/2 here, this right here, from here to here, looks like a sine curve. So the cosine and sine curves really could be the same thing with a slight phase shift. Okay? So if it's cosine, it starts up at 1, but if it was sine, it started at 0, 0. But if you do a phase shift, by the time you reach that, it looks like it's starting at the same thing. Okay, so just keep in mind, the curves really are basically the same curve with a slight phase shift, okay? So let's go for one. Notice I threw lots at you here because the rules for the A, the B, the C are the same for cosine as it is for sine. The only difference is where you start your graph. That's it. Everything else stays the same. Okay, so we're always going to start with the amplitude because that tells us how to mark our vertical axis. So my amplitude here is 2. So it means I'm going to go as high as 2 and as low as -2. We're going to go for the period next. And we know that our period is always 2 pi divided by b, and this is true for every sine and cosine curve. All right, and I notice my b right here is this 2 pi. Okay, so I'm going to do 2 pi divided by 2 pi, which equals 1. That means 4 lines out, I'm at 1. Okay, so 4 more lines out, I would be at 2, right? Or 4 to the left, I would be at -1. Notice I don't have pi in my scale. That's fine. So this axis, it just needs values and a scale to be set on it. It doesn't matter if it includes pi or if it doesn't. To be honest, what we have going here are still radians, but we're in the decimal system basically instead of using pi. All right, phase shift. So remember the phase shift is C over B. Recall that the C is always opposite what it looks like. So instead of positive 4 pi, it's going to be negative 4 pi. So I'm going to do negative 4 pi divided by my B, which was 2 pi. Again, my pi's cancel, and I'm left with negative 2. So that means I'm going to shift over negative 2. So my normal cosine, okay, my normal cosine would normally start up here at 2 or at 1, but because of the amplitude, I'd start at 2. But instead, I'm going to shift that starting point all the way over to negative 2. So normally, I would have ended my cycle at 1, okay? But if I shift that over negative 2, I'm going to end it at negative 1, okay? Notice here on the cosine that where I start and end again are the similar points, right? Just there. So halfway in between is going to be my absolute lowest point. Okay, so I'm actually going to hit my zeros in between there. So I'm going to start up, come down, go up, and I get both my hills there. And that's my cosine curve. So the difference is I start up instead of starting at 0. I find my amplitude the same way, I find my period the same way, I find my phase shift the same way. It's really the starting point that's the difference between the cosine and the sine curves. All right, last page. All right, you'll notice I throw one more thing at us here, okay? I still have my amplitude of A, the absolute value of A. I still have my B, which is going to affect my period and get used on the phase shift. Still have my C in the phase shift, okay? But you'll notice the last one I've added now is D, which is my vertical shift, okay? And what this vertical shift does, okay, is it's going to give us a new, for lack of a better way, I'm going to call it midline, okay? Currently, we've been using this x-axis as that middle line, okay? But if we have a D, a vertical shift, it's going to give us a new midline, okay? So, graph one period of the function, y equals 2 cosine 1/2 x minus 2. Okay, always start with amplitude. My amplitude is A right there, which is 2. My period, which is going to be 2 pi divided by b, anytime we're dealing sine or cosine. So my b this time is whatever's multiplying times the x, so my b is 1/2. So 2 pi divided by 1/2, which is the same thing as 2 pi times 2 over 1, right? Keep, change, flip, which is going to be 4 pi. Okay, so 4 spots out. 1, 2, 3, 4 is 4 pi. 1, 2, 3, 4, negative 4 pi. Halfway between there is 2 pi, right? So really, if you think about it, every line on my graph right now, every increment is a pi, because I'm at pi, 2 pi, 3 pi, 4 pi, and so on. All right, phase shift. Is there anything added or subtracted inside with the x? They've got to hold it in there with the parenthesis. And in this case, there's none, okay, because there's no c, which means my c equals 0 here because there is nothing, okay? Now, this is the one that's different now, though, the vertical shift. So my vertical shift is the D, okay? And by the way, it's the exact sign you see it at. You just take it. So in this case, it's going to be negative 2. All right, my amplitude was 2. Okay, so I'm going to take, and what this does is this gives me, remember this vertical shift, it's going to give me the new midline. So what I do is I go down to negative 2, and I kind of just dash my midline right there. Okay, that's my new midline. That's what that vertical shift is going to do. Just do that, okay? And that means because my amplitude is 2, I'm going to go 2 above that line and 2 below that line. Okay, my cosine normally starts up here, right? But I've shifted down 2, so I'm going to start here. I'm going to end there, again, 4 pi out. Halfway in between, I'm going to be at my absolute lowest point, which is going to be 2 points down. And then I'm going to hit these points in between. So I'm going to come down, and back up. Okay, there's my graph. So quick note on this one, my domain, because I did one period, is from 0 to 4 pi because of my change in periods. Be careful on this range. Because I did this shift, I don't get that symmetrical look of like -2 to 2, like I would with a regular amplitude. So I shifted everything down to, it would be nice if it's -2, 2, but what this vertical shift does is it subtracts another 2. So I'm actually down as far as -4 and up as far as 0. Okay. So quick note here. Okay, and this is actually going to help us on the first one. If I ask you to graph a sine x, you would mark this one, okay? But you'd start at 0 and you'd go up, down, up. Okay, if I ask you to go a cosine x, you're going to start up, then down, and then back up. Okay, that's the difference between the two graphs. So keep that in mind. It's a starting point is the only difference between those two graphs, okay? One period takes you back to the point you started at after a full cycle of ups and downs, okay? All right, last one for this examples is find an equation for this graph. This is the first thing I'm going to say because I need to make sure you understand this. There are more than one correct answer. And can I just tell you, when I say that, I mean like there's infinite number of correct answers here. Okay? So don't think that because you were going to do something else, it's different. Okay. Some things we need to know. Number one, we need to choose. And I say that exactly like I'm saying. We need to choose if we are working with a cosine or a sine curve. Okay? Personally, I go from where I'm starting because I see that I'm not starting at 0, 0. I'm going to call it a cosine curve. Okay? So I'm going to choose, and this is important to know, I'm choosing cosine because it starts up. Okay? Notice that's what it did up here on this graph. It started up, okay, for the cosine. So that's why I'm choosing it. Okay. So I'm choosing cosine. It's important. You need to choose one of them, right? We need to know an amplitude because that's part of our equation. Amplitude, it looks like I go up as high as 3 and down as -3. So it looks like my amplitude is 3. All right, for my period. Okay, a quick reminder. Period is always 2 pi over b. Now, this is a little bit different. We can figure out the period, and we have to figure out the b. That's what we're coming back to figure out, okay? So that we know the a, but we need to find the b. So I need to check. If I start up here, I come down to my lowest, I come back to here. That's one full cycle, right? Between there and there. And you could have started anywhere on the graph, I'm going to be honest, but I chose to start right there on the y-axis. So it looks like from start to finish of one period, I have 4 pi, okay? Don't ask why I'm... Okay, so this is equal to 4 pi because it took me from 0 to 4 pi to get one full period in. What I have right here is an equation. I'm trying to solve for b. I can't solve for b when it's in the denominator, so I multiply by b. I get 2 pi, these b's canceled, equals 4 pi times b. I'm going to divide by 4 pi. My pi's cancel, and I reduce that fraction to 1/2. So my b is 1/2. So y equals, I decided on cosine, okay? I need an a, I need a b. Because I started on cosine, I do not have to worry about a phase shift because I'm choosing to start my cycle at 0, okay? Or my period, I should say, instead of cycle. You could do a sine and do a phase shift. I'm trying to keep it as simple as possible. So I'm going to plug in my a, my amplitude of 3. I'm going to plug in my b of 1/2. And I chose not to do anything more as far as phase shift because of the way I chose my equation. This is one correct answer for this graph. Okay? You could use sine. You could put a phase shift on there. I could do cosine with a phase shift. I could have said that it technically started way over here and I had to shift this all the way over here, but I chose not to, okay? There's infinite number of solutions for this. This is one correct answer. Okay. Once again, can't stress enough. Practice, practice, practice. Okay? You can easily sketch this graph on a piece of notebook paper. Remember, the fourth mark out is the most important. That's where your period is, okay? No matter if there's a phase shift or not, you put your period 4 marks out, okay? So you're trying page 533, 3 through 66 by 3s. Please, please, please try them. These don't get easy, okay, until you've had some practice with them, so please practice them.